Hello students, this is Manoj and today we are going to study about thermodynamics. What is thermodynamics? Thermo means heat and dynamics means the change or the flow. The term thermodynamics deals with the relationship between the heat and the work, and it includes all the kinds of energy interaction. So we can say that the chemical thermodynamics is the branch of science which deals with the energy changes in the chemical reactions. In thermodynamics, we study about the various laws of thermodynamics, which is actually applicable for macroscopic system. Macroscopic systems are those systems which involves large number of molecules or which deals with the bulk of the system. Examples of macroscopic properties are pressure, temperature, volume, composition, surface tension, viscosity, density, enthalpy, entropy, etc. You can see that all these properties belongs to the bulk of the system, that is the whole of the system.
The study of thermodynamics is based on the three generalizations, which is known as the first, second, and third law of thermodynamics. One of the significant aspects of these laws are they are based on human experience, and actually there is no formal proof of these laws. But we don't expect anything contrary to these laws. Anything, a lot of important laws of physical chemistry can be deduced from the laws of thermodynamics. But the two most important application is in predicting the feasibility of a process. It could be physical or chemical. Feasibility means whether the process can occur or not under given set of conditions of temperature, pressure, concentration, etc. Thermodynamics also helps in determining the extent to which a reaction would proceed before attaining an equilibrium. Therefore, it is capable of predicting the yield of the product. Also, it has got wider application in physics and engineering field. But there are also limitations. The most fundamental limitation is that although thermodynamics is capable of predicting the feasibility, direction, and extent of a given process under a given set of conditions, it cannot tell us anything about the rate at which the process proceed. That is, the speed of the reaction or the time for the reaction to reach the equilibrium. Thermodynamics only concerns itself with the initial and final state of the system. Therefore, it does not give us any information regarding the path or the mechanism of the process. And the most important, the laws of thermodynamics are applicable only to the matter in the bulk, that is, the assemblage of large number of molecules, that which we call the macroscopic systems. It does not concern itself with the individual molecules of atoms. Thermodynamics actually ignores the internal structure or the microscopic properties. Now let us try to understand some of the basic terms that is involved in the thermodynamics, like system and surrounding. System is the part of the universe which is under our observation, whereas surrounding is the rest of the universe. The system is separated by the surrounding by a boundary, and the whole universe is system plus surrounding. Now let us try to understand the three different types of system involved in thermodynamics. They are open system, closed system, and isolated system. Open system, the system in which the exchange of matter as well as energy takes place with the surrounding. For example, a hot cup of tea, a open hot cup of tea, both matter as well as heat exchange with the surrounding. Now let us consider the closed system. The closed system is the system in which there is no exchange of matter, only energy exchanges with the surrounding. The example can be if you put a lid on the above cup containing the tea. Now only heat exchanges with the surrounding. The matter is contained within the system. I'm talking about the isolated system. It is the system in which neither energy nor matter exchanges with the surrounding. The example of this system is the hot tea in a thermos flask. Well, let us now try to understand what is state of a system. A state of a system is defined by its measurable macroscopic properties, by the value of measurable macroscopic properties like pressure, temperature, volume, composition, etc. If any change occurs in the measurable properties of the system, we say that the system is in a new thermodynamic state. Even a single measurable property changes, the system is supposed to acquire a new state. Among these measurable properties, there are the properties which depends upon the amount of the substance. Such properties are known as extensive properties. For example, volume. Greater the amount of the substance, higher will be the volume. Well, now even you could guess what could be other such properties. Well, they are mass, energy, surface area, heat capacity, internal energy, enthalpy, entropy, free energy, etc. On the other hand, there are properties which does not depend upon the amount of substances. Well, they are pressure, temperature, density, viscosity, refractive index, surface tension, specific heat capacity, molar volume, etc. In thermodynamics, these macroscopic properties are also classified as state functions. State functions are those properties which depends only on the initial and final state of the system, and it does not depend upon the path followed. For example, pressure, volume, temperature, internal energy, enthalpy, entropy, free energy, etc. come under this classification. State functions only depends upon the initial and final state of the system, and it does not depend upon the path followed. And there are path functions. These are those properties which depends on the path followed by the process. For example, if a zinc rod is dipped in copper sulfate solution, the heat is evolved. But if the same reaction takes place in a galvanic cell, the heat is not evolved. Therefore, one of our examples of path function is heat. Now let us consider another example of path function, that is work done by a gas. Now there are two setups, one in which the gas expands from a volume V1 to V2 in a very slow manner, and the other setup in which the volume expands very fast. If you look into the work output by these two expansion, you will find that the setup in which the gas expanded very slowly has much higher work output than the setup in which the gas expanded very fast. This proves that work done is a path function. It will depend upon the manner in which the process was carried out.